Optimization. What is the maximum vertical distance between the line y equals x plus 2 and the parabola y equals x to the second on the closed interval from -1 to 2? Let's get started. To use calculus to solve the problem, we will be using a function that describes the vertical distance, and we'll use the first derivative and show that it's a maximum value that we have. So let's graph the two functions, the line y equals x plus 2 and the parabola y equals x to the second. You could see that they intersect also at the endpoints of our interval -1 and 2, as you could see on the graph. So this is my -1 right here and 2 right here. So those two endpoints are the intersection points. We need the vertical distance, and it looks like we're not going to be right here or right here, somewhere in the middle, So here's a graph that shows the vertical distance, and I use green for the maximum or the vertical distance. And since it's called vertical distance, we don't want to call the function between them as y3 or f of x, so we call it v of x. So what is v of x? Going back to the graph, I do have these 2 points. This point right here on top is in blue because it belongs to the straight line, so I could call it x, and in general, since it's a mover, we write it as x plus 2. That's for the y value. The bottom one, it belongs to the parabola, so we'll call this point x and x to the second. And we need the vertical distance, so the vertical distance will be v of x, which is y2 minus y1. That's how far they are apart. So I will be using x. Let's go here, and the y2 is x plus 2 minus y1, which is x to the second. Of course, we are on x greater than or equal to -1 and less than or equal to 2. So now v prime of x will be the derivative of x plus 2 minus x to the second. Derivative of x is 1, derivative of 2 is 0, minus x to the second, the derivative will give me minus 2x. Setting v prime to be equal to 0, we will have the following. We have 1 equals 2x, which implies that x equals 1/2. So x equals 1/2 is our critical point. Going down to the line at the bottom side, v prime of x at this point, which is 1/2, that's our critical point, v prime is 0. Going to the lower line, which is v of x, at x equals 1/2, if you plug in 1/2 in the v of x, and this is our v of x right here, we get the value 9/4. Let's go back to v prime. V prime, let's fix that. 4 is 9/4. That's the value at x equals 1/2. So The endpoints also, since we are looking at v of x, that's -1 and 2. The values are 0 and 0. Just looking back at one more time at v of x. So if you plug in -1, you end up with 0, and you plug in 2, you get 0. For v prime, to the left of half, it's positive. Just plug in any number like 1/4 in v prime, and this is our v prime. So 1 minus 2 times 1/4 will be positive, and plug any number above half, something like 1, in v prime, will end up 1 minus 2 times 1, which is a negative number. So that's a negative, which means the graph is increasing, then decreasing, and that gives us a maximum at 1/2. So therefore there is an absolute. Why it's absolute? Because we don't have any other maximum value to compare it to. An absolute maximum at x equals 1/2, and the maximum distance is v of 1/2, which is 1/2 minus or plus 2 minus 1/4, just by plugging in that in v of x, which is this right here. So 1/2 for x, and x to the second will be 1/2 squared, which is 1/4. So finishing this, I end up with 9/4, as I showed you down below. That's the maximum, which is about, or actually exactly to 2.25. Another way to do it is the following. V double prime second derivative is -2, which means it's negative. Negative means concave down. So the only critical point is x equals 1/2, and v prime at 1/2 is 0, so we have a horizontal tangent. V double prime is always -2, so v double prime at 1/2 is still -2, which is negative. That means it's concave down. This means it's a horizontal tangent. So if you have a horizontal tangent and the graph is concave down at that location, we have an absolute max. And that's the absolute maximum that we have, and that should do it. So either you could do it by increasing, decreasing, compared to the endpoints, or do v prime equals to 0, v double prime is negative, which is an absolute max, because that's the only critical point that we have, and that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.